Hey guys, so I am here today to explain about my topic called FedChain, which is the ML model trainer. So let me introduce myself. I am at Kowshal from DIT. So I'm here to explain the topic FedChain. What is FedChain? FedChain is a federated learning based on blockchain. Yeah, so that's how FedChain is um, elaborated. So let's get deep into it and understand what is the objective and why have I come up with this project. So so in this we'll discuss about the this will be the contents of the presentation. So let's come with the problem statement. So there's always been a requirement for a really good model trainer. So each and every machine learning developer needs someone to train their model with vast and huge, enormous amount of data. So where can they get this data? Either they can generate it or they can get it online. But even the data that's available online is not surplus to train the data as that will meet the requirements. So if you can see, the accuracy of the model is directly proportional to the training data given to the model. So to solve this problem, we need some system in which we can get data and the model keeps training. So that's why the concept of federated learning was launched by Google. What federated learning basically means is that you can train the data based on the current users. As in, if you know about Gboards, that's Google Boards, how Gboards works is like you enter text into the keyboard. The machine learning model present inside your device computes the data and gives prediction based on computations by the other people within your organization or in and around you. How that's done is using federated learning. Let's say you have a model named Model A in your device, and your peers, that is five of them, have models namely B, C, E, and F. So you five have been constantly typing names to, let's say, your college faculty. So the context of the message is usually the same. So if you keep using Gboard, at a point of time, Gboard will start recommending this, recommending the text that you have to type. How is that possible? So each and every phone or a device has their own model within them. So if you keep giving inputs, that data is being trained, the model is being trained with the data you have given. So how does model A, that is the training of model A, affect data in model B? So there's where the concept of federated learning comes in. The model that is trained in your device is sent to the cloud or the local cloud that's available near you. And all other models are also sent to the main cloud. All these models are averaged as in a main supermodel is for. This model is sent back to the devices in their, this model is sent back to the devices, and the new model contains the data as an input that was given by you. So each and every one can have the data that you had given to train the model. So this is how this model will come to know that, okay, so Kowshal has typed good morning, sir. So when I say good morning, sir, that will be recommended in yours, that will be recommended in your Gboard as well. So that's how federated learning works. This interesting concept had a really big problem. The main problem about federated learning, if you could have figured it right now, is that it's really centralized. Everything is based on the central cloud that's being given, and the main and most important thing is that the model, all the models reach the cloud. So if the cloud is tampered, all your models will be tampered. So it's being centralized makes two places really tough to handle. That's tampering the main model, and if a central cloud, and if the cloud is stops functioning, then the whole system will be down. So that's where federated learning has a little below a curve. So that's why we came up with the idea of FedChain. What FedChain is, that it's federated learning with blockchain. But before going into federated learning, I'll just discuss a few advantages of federated learning in detail so that we get to know what are the pros and cons of federated learning. So federated learning is efficient in managing data. So how can I express that? Is like, let's say you have a model in your device. So the data you give to that model remains inside your device. The data is not being transferred. The thing that's being transferred is the model that's being trained on your data. So your data remains private and secure. So that is ensured by federated learning. But if you can consider this point, the model that has been trained, let's say we have some personal details that we enter into our keyboard, that is the mobile keyboard. That data also gets trained by the model. So if you use that as an input, that will also get trained by the model and it will start suggesting into other devices. So the federated learning model should be well enough that the data that's being trained is legit and the data that's only required needs to be trained. So yeah, Google Board is working on it now. They have introduced incognito mode as well. Yeah, so passwords and stuff are already entered in incognito mode. So now they've come up with that come out with of that error. So high risk possibilities, of course, like because it's really centralized. If you tamper the central cloud, then everything's down. So that's highly possible that you have an error. And algorithm selection, how that's a disadvantage is that let's say you have a model. That model works on only one particular kind of data. For example, I have a model that decides whether the given picture is a cat or a dog. It doesn't know anything about a lion or a let's say a tiger or something. So if you click a picture of a lion and say it's a dog, it can either tell it's a dog or a cat. It can't define whether it's not a dog or not a cat. So in that case, because there's a flaw in the model, actually a model should say that it's neither a dog nor a cat. But if there's a flaw in the model, the whole system will come, the whole model training will go collapse, and hence the final product of the or the model that's obtained from the federated learning is a total waste. So that's why the selection of the algorithm, that is the machine learning model, should be right and should give favorable outputs. So these are the disadvantages and advantages of federated learning. Now let's come to FedChain. What is the motivation of me working on FedChain? So the main motivation is to change the traditional system of machine learning training, first of all, because like we have lots and lots of machine learning developers all around the world right now. People have started gaining interest into machine learning, but the main drawback they face or the main setback they have is the training of the model and the data they require. So the motivation for developing FedChain is that each and every model trainer should have a set of people who will be training their model based on the data that they have. So that can be achieved via FedChain. I'll explain the process how that will work in the further slides. So the objective, the last objective would be a, BCFL, that is a blockchain based federated learning system. How that will work is that why we need blockchain based federated learning. Yeah, I didn't explain that as of now. So the requirement for blockchain in federated learning, of course, we know that blockchain is decentralized, but how does that help, right? So if you consider the point of being decentralized and distributed, a blockchain is decentralized and distributed. The thing that happens here is that you are in a peer-to-peer network. Now, in this case, if you are in a peer-to-peer network, it really becomes difficult to tamper the or hamper the process of training. Suppose in case of single node gets affected, the whole other process or all the other nodes are still being in the training process. So that's one plus point. The second plus point is that the file, if you want to tamper the machine learning files that's been averaged, that's really infeasible because the files will be into a blockchain. And tampering a blockchain, of course, is infeasible because of its high cost of mining. So that's why BPFL is a topic that's currently being investigated on by different scientists all over the world. So yeah, so that's the main reason that I've thought of using a blockchain-based federated learning. So this is the basic methodology that I had planned for. There'll be a data miner. So I've named the main algorithm as data miner. So there'll be a model provider and a data provider. A model provider is an ML developer who gives us the model, and a data provider are people like us who have the data related to the model. Let's say I developed a model that will find whether a given animal is a cat or a dog. So if I have an animal or a pet with me, or I see animals daily, so I can be a potential data provider who can provide data for that particular model. Let's say I have a dog, so I can keep posting pictures of dogs and say that it's a dog, so that the a machine learning algorithm gets to know that it's a dog and it's trained on that data. So this is how it will work. So a model trainer posts a model inside the data miner. A data provider also subscribes to that model based on the data he has, and the model gets trained continuously with the BCFL. I'll explain the algorithm how it gets trained in the further slides. So it gets trained, and you get a final average model. And after the model provider finds that the accuracy of the model is quite good enough, so then what you do is you send the trained model to the model provider, and then the payment is done, and the data provider receives the incentive for giving his data. We also had planned for a public use model, which is still under development. So the public use model is like, we all know that machine learning is the future of the world. So we have some models that are trivial and needs a lot of data. For example, let's say there is a speech assistant, for example, speech assistant as in a chatbot. If you have a if you give a chat, this should be the response. This should be trained to the model based on the data. So if you start training this model as FedChain owners, we will pay incentives to the data provider. And let's say after 10 years, your model will be so trained enough that it can give responses on its own, like because of this huge enormous amount of data it has, and the training it has got. So this is how the public use models will work, and then these models will be sold to companies who require them. So that's how the public use models will work. We're still working on it. So the concept, as I explained, is federated learning, blockchain. The main thing that I have to explain here is aggregation. What aggregation is? So you have two models. Let's say a model is trained by only A, and another model is trained by only B. They are the same models, but the pickle files are different. So these pickle files can be averaged together to, let's say it's called model AB. So this process of averaging two pickle files is called as aggregation. So that is the aggregation of the averaging the model. So the literature review is basically about federated learning. That's trivial at this point because I've explained a lot. I will go to the working because it's a bit time consuming. So the framework I have used to write code is Solidity and Truffle. That's the framework for blockchain. Ganache, that's the token provider for blockchain. That's the Ganache provides this fake keys. And we have IPFS. IPFS is Interplanetary File System. It's a blockchain-based file system that promises to transfer files from Mars to Earth in 4 days. That's a pretty interesting concept, but that will be out of the topic if I start talking now. But what IPFS is basically is it keeps storing files into a public ledger, and the files, like the file, will be converted into a hash, and that hash will be kept storing into the data of a blockchain. And after you, if you require the file to be opened, you access that hash, and that hash will be used as an URL to get to the blockchain. So next we have React.js for the front end. That's the front end framework I've used. Then we have the inputs and outputs. So my, as I said, my input will be the ML model, and my output will be a trained data, and the data will come from the data provider. My output will be a trained model. So this will be done using blockchain and federated learning. So let me give you a demo that will make it quite interesting of how the thing is being displayed. But before we go to the demo, let me show you the endpoints that I've decided for this project. The model template that there are six main endpoints for this product. First is the model template. This is where the user will post his model so that the data provider selects the model. Then we have the selection where the data provider selects the model. Then we have another endpoint that is collection module. What the collection module does is like when we get the data is collected, and as soon as I'll have a bucket, a variable called bucket. If I fill, let's say the bucket size is 10 as of now. So if as a user in my device, I fill the bucket with 10 data, and that data will be trained. So I have a local model that's trained with a bit of data, that is 10 data. And this 10 tuples of data, this small model will be sent for averaging. After averaging, that model, how it's sent for averaging, it will be sent to the IPFS client, and that hash will be broadcasted to everyone. So that's the task of the collection module, that is to send this to the, after the bucket is filled, the model is trained and sent to the IPFS module. So what my IPFS endpoint will do is it will put the file into IPFS and give me a hash for that file. So that's the IPFS client endpoint. And last we have the broadcast. Last second we have the broadcaster. What the broadcaster does is the hash we receive from the IPFS is broadcasted to each and every node inside the blockchain network or the Ethereum network. And in at this point of time, we have the hash with each and every node. Now we have the Fed average function. What the Fed average function does is it takes the hash, it downloads the file into each and every local node, and then the new model is average. So that's how the Fed average function works. So these were the endpoints of FedChain. Now let me get into the actual working. Yeah, so for this, I have used the IPFS client. As you see, my client will be from Incura. Incura is an public ledger blockchain for file system. So it is the one who is providing me with IPFS, and these files will be put into Incura's public ledger as of now. But after we get a few, after we get more into this project, then we can create our own public ledger for a file system, blockchain based file system. So as you can see, I get my hash here, yeah, and this hash is sent. So this is the hash of my file. Yeah, this is the hash of my added file to Infura, and this will be the link if I want to access that image. And after that, I use this hash that is sent into the broadcaster module, and the broadcaster module will average the function. Like the broadcaster module will broadcast it, and then I have the average function, which will average client one and client two. And then as of now, I have used Flower client to average the models. Yeah, this Flower client, I'm not really good with my Python and Flower client. So I've searched online for this code, and this code was available online. This will give you a basic demonstration of how the Fed average function will work. And let me show this working here to you. Let's say I have this is the model provider. The Keras model will produce, this will start this service, and it will distribute the modules to the clients. Let's say we have client one and client two. I have two different data sets. Fine. So after I create the data sets, the model provider will distribute the data. As of now, that's how it works. So the model provider will distribute the data and send it to them. So this will work as if the data of client one is totally different from data of client two. I'll show that. I've also represented that as graph. And then we have the Keras module that will return me the data that I have. And this data is trained into the local model that I have, and then these will be averaged for 10 times, as the bucket size is set to 10 times, and then the final average model will be displayed. So let me run this for you. I'll run it on port 5001. So I'll just start my model provider. Yes. I'll start my client one. I'll also start my client. Yeah. So if you see my model provider, one second. If you see my client provider, it will load up uh, a graph showing the data or for the data representation of how the model client one and client two is working. So I guess that should show up in 2 seconds. So if you can see the data that I have received, that is 0, 1, 2, and 3, and 8. This is totally different from the data of the second client, that is 4, 5, 6, 7, and 9. So the first client would not know anything about 4, 5, 6, 7, and 9. If I give it a data on 4, 5, 6, 7, and 9, the prediction will be totally zero. That because it knows nothing about that data. But and the same goes for client 2. It will know nothing about 1, 2, 3, and 8. So let's see how the averaging works and what's the percentage of its prediction. I'll close this so that my prediction. So now we'll be looking into the model provider. So there'll be 10 rounds of training here. So if you can see here, my weight files are being generated, which has the final pickle files. So these pickle files will have the aggregated model. Each and every model is trained more than the previous model because the data keeps averaging on providing a bit more data to each and every time. So I'll show you the accuracy after 10 weight files are produced. I've set the limit to 10. Yeah. So after 10 rounds, this is the most important part. Yes. So if you see into my client one, the history of the evaluation accuracy to check, it starts from no, not the evaluation accuracy. Let's check for the yeah, val accuracy. So this is the value accuracy is the accuracy of my model that I've trained. So at the initial, it was 50%. If you remember, only 50% data was available with me. The other 50% was unknown. So after training it on the whole 100% data, the accuracy was 50%. And in the second round, it's 58. Then it goes to 67. It jumps to 69, 67, 66, 76. And at last, my evaluation accuracy goes up to 98%. That's how the model is working. So if you see for client to the same, it starts from 47. It hikes up to 95 at the end. So that's how the accuracy keeps on increasing. This is the total accuracy, that is 90%, 93%, 94, 95, that keeps increasing. So if you keep going more and more and more, the accuracy keeps increasing till 98. So the last file that is the most accurate model will be in my round 10 weight file. That is the pickle file. I guess I can open a pickle file as well. So because the editor doesn't support a pickle file. So the last pickle file will be the most trained one, and hence you have a model that really trained and can give more better prediction. So this is how the system will work for a federated learning based blockchain, like blockchain based federated learning. So that was a small initiative that I've taken to reach a really big goal of having a federated learning system that gives a model training process for each and everyone available there. This will help out many people to train their model easily with real-time data. So you don't have to actually produce data for a model. So yeah, that's all about FedChain. I hope you like the idea and concept. Thank you.